We are streaming live about several topics in software engineering, everything from robots and self-driving car to well-architected apps. We are here in this segment to talk about the well-architected framework, which has been developed to help you guys demonstrate that your architecture works and that your software is ready for its mission. And it's quite a challenging task to do. If you've been to a couple software projects, you know how diverse they are in terms of technology. So establishing these guidelines, these architectural guidelines, is not so simple, and it must be done in a way that fits every customer. So let's start by jumping right into the well-architected framework white paper, and you can download them right here from the well-architected page. And today we're going to talk about the reliability pillar, so I'll go directly to that. And the first thing you see is these design principles. And we're going to talk about those a lot, so if you can't hear me clearly and loudly, please talk on the Twitch chat here on the side. I'd love to hear what you think. If you have questions or any issues at all, I'm here with you guys, and the idea of Twitch is making this interactive, so the more we talk, the better. And the design principles are to test recovery procedures, so we are going to see how we can test the software that we built in a way that is valid, that truly prepares you for the cloud, so that you can test it at the same scale and the same level of service that you would expect in production. And also to do this automatically, so that when you need to recover for any way, you don't need to put up a war room, wake up a lot of people, and just recover your application. And one very important example of that I always like to show is about Netflix, because Netflix do this very well. And another important thing here is I have some links to share with you guys today. So I will open my GitHub lists and show you guys what I have prepared for today. As we talk about in the security white paper, you should every time that it's possible use MFA. So I've got two-factor authentication for this GitHub account. We're going to see about how to set that up for AWS as well. So I'm in. And on my lists, just let me check that it's public. So yeah, I need to make this public. And now I can share this link with you guys. And a lot of the resources that we're going to talk here is on this, are here. And about the structure of today's episode, let me show you exactly what we are going to do. So in the reliability pillar of the well-architected framework, we have those best practices posed in the form of questions. So for example, how are you managing AWS service limits for your account? How do you plan your network topology on AWS? How does your system adapt to changes in demand? How do you monitor AWS resources? And so on and so forth. In this episode today, we will talk about the design guidelines, as we are doing now, and then talk about these first three questions. So This way, we are doing two things. We are covering the entire framework question by question. We are going to go as deep as possible within each one in terms of implementing them actually. So we're going to episode after episode go deeper and deeper into those answers until we can share as much as possible about them so that everybody has an easier time being well protected. And that, although that would be wonderful, I know that everybody's business is different, so there's only so much we can agree upon, but I hope I can show you what's being done in the AWS customers with the most recent tools and services and so on and so forth. So, well, coming back to where we were on the design principles, automating recovery from failure, what I'd like to pick here is this link from Netflix. Netflix Flux. It's not. I thought it was here. I will go directly to Netflix Visceral Failover. Would be a good way to find what I want to show you. I showed that on previous videos, and sorry it took me this much to find it, but here is the overall idea. You see this is the service map for Netflix. They built this intuition of flow using this tool called floats and this visualization using this tool called visceral. And you see the error rate in one of the US regions that they use starts to increase, and they start to offload traffic, and you see that they have to do it slowly. You can't just offload a lot of the traffic to the other regions because they're not scaled to handle this extra amount, so they programmatically redirect traffic and scale the remaining regions so that then they can vacuum this region completely, do the maintenance that needs to be done, correct the bug, deploy again, and so on, and then come back with this, like, and back to service, and nobody even sees anything happen. So this is what we're trying to achieve with automatically recovering from failure. Of course, that it is very different when we talk about Netflix case, that it's distributed across 3 different regions of AWS. We can have very similar results with less complicated architectures, perhaps using using just one region, for example. In terms of high availability for many customers, this may be just well. So we're going to investigate a bit when we talk about recovery from failure and high availability and things like this. Another idea is to scale horizontally to increase aggregate system availability. So let's try to add more machines instead of growing the machines, because when we get to a point where we have servers failing at a certain rate, you don't want to have this being like a huge problem. It should be just, you know, one more routinary event that your architecture can handle gracefully. You should stop guessing capacity, because when you think about scaling horizontally, it's very hard to determine in advance how much you're going to need and prepare for it and keep doing this exercise of guessing the capacity needs. If we automate for this load perception, and not only for load, I mean, we could be talking about the scheduled events. The important thing is automating If you're reacting to users' growth or the popularity of your product, that's fine. If that's automated trigger that you put to scale the night before Christmas, that's fine as well, as long as you are not just like guessing and putting it in, but adapting the way you should. And we're going to manage change in automation. Everything we do, we're going to try to do automatically. As we did in the first episode in the series that you can see in the videos tab on Twitch, we did a small introduction to CloudFormation using a simple S3 bucket. Today we're going to deepen this CloudFormation introduction, creating VPCs for our network infrastructure. So let's jump right into that. So if you are just starting now, thanks. I'm glad to see Gina here and everybody. Please, if you have any questions, just say hello on Twitch chat and anything you'd like to add or comment. I'm here with you guys to talk about things you want to talk about. So feel free to send any feedback that you think is important. In this series, just for those who recently started, we are talking about software engineering and application architecture using the AWS well-architected framework to help you build using architectural best practices developed at AWS. And today we're going to talk about the first 3 questions of the reliability pillar. So without further ado, the 3 questions again are how to manage AWS service limits, how to plan for network topologies, and how to do change management. On the first question, how to adapt in demand. So let's go right into the first one. In the GitHub gist that I just shared with you, there are some important links. So the first thing to understand is that AWS is not unlimited. There is one of our customers, when he was doing his planning, he was afraid that the AWS wouldn't have the capacity to handle his huge simulations. And he just said, well, it's like just a few cents per instance. I would just do while true run instance and see how much they got. I don't mind if I pay a couple bucks, but I'll just see how many they can spin. And really quickly, you get to discover that it's not totally unlimited. You are bound to this service limits. Today we're going to talk a lot about VPCs. So let's start by looking at the VPC limits. So we got a link right there. So you can see that, well, if you're not familiar with Amazon Virtual Private Cloud or VPCs, those are software-defined networks in which you can customize to any topology or networking infrastructure you need. So it's a software-defined networking by AWS, totally integrated with the other services and full of features we're going to explore in this series. And they are limited to 5 per region initially. So this limit is very important. If you are in production, you may not have 5 VPCs may be enough, but if you're in development and test, 5 may be too few. So it depends on how you manage your accounts. And another thing you see here is that the multiple number of VPCs in the region and the number of security groups cannot exceed 10,000. So beware of these limits. And so on and so forth. You will see there's a limit of subnets per VPC, of cyber blocks per VPC that you get, on virtual gateways per region, and so on and so forth. So And if this is too little for you, you can always request us to increase this limits, and I will do this just now. And perhaps we can see how long it takes, but that's very simple process. So you select service limit increase for VPC, and this is per region. Again, mind that this is per region. So I use the Ireland region a lot, so I'll say that in Ireland, I want to have my total number of VPCs per region to be increased to 20. And I want to ask the same for US East 1, Northern Virginia, because that's another region that I frequently use. All right, and so on and so forth. You can go and add service limits increase for all the resource limits that you need increase it, and answer if this is a business impairing question or not. And this, in my case, I have a business support, so this is the service limit that I have, and I'll give a brief description of the case. So I'd like to test more environments at once, especially when streaming live on Twitch. Thank you. And by the way, it's okay, submit. And that's all you have to do to request a service limit increase. And this, why this has to do with reliability? That's a very fair question at this point. And it's clear when we get to instance types, because on EC2 service limits, let me find where those are. Here it is, EC2 service limits. So on the EC2 service limits, you will see the oh, I can view them live on the console. So just go to the console and from the navigation pane, see limits. So let's try that. EC2. Here we go. So you can see that for most instance types, I have a limit of 20 of those per region. So if I need 21 or 25 to scale up, to adapt to my running demand, I would need to request a service limit increase. And this is why it's probably a good idea to use a diversified fleet, because you can leverage better service limits. Perhaps if your groups on auto-scaling groups can use more than one service limit at a time, and this is how it works. So again, see that this is not for all instance types. For some very large instance types or instances with special resources such as FPGAs, you only get 2 of those per region, or even 1 for the D3s. So make sure that if you're planning to launch a huge cluster of those, request your service limit increase with a bit of advance. Okay, but that's not all you can do. There is recently been service limits API released. So for some services here in For example, auto-scaling is one of those services that there is a describe account limits API that you can use from the CLI. So here, let's try this command. I have a terminal session here on my iTerm. So running this command shows me that I have a maximum of auto-scaling groups of 200 and but I'm using 0. So that's an automatic way to look up for service limits. And if you want a specific one, remember that we have in the every command in the AWS CLI, we can pass a query and get just a part of your JSON. So I can query for just the max number of auto-scaling groups, for example, that would be 200, and so on and so forth. So you can see that for the services that support service limits API, this is quite simple to automate. But there are some other alternatives. In the Trusted Advisor, we recently added a service limit dashboard to CloudWatch metrics and things like this. But to be honest, the best way I found to monitor service limits is by using a CloudWatch alarm. So you can see how you're doing against the limits that you have set by periodically checking and running some evaluation. And this can be in terms of two services, usually CloudWatch and CloudWatch alarms, and also AWS config. So I found an implementation of each of those that I'd like to share with you. And it's important to understand a bit about the difference of those services. So let's go to the CloudWatch console and to the config console and understand the services a little bit before we proceed. So here in the CloudWatch, it's a management tool, right? So here in CloudWatch, you will see metrics data. You will create alarms. You can even have alarms for billing. But usually we're going to be talking about metrics, any kind of metric. We could be talking about CPU utilization or memory utilization or size of files and so on and so forth. But another thing that you can do is send custom metrics to CloudWatch. You can measure and monitor anything at all. So what this guy proposes, and this is an approach used quite frequently up there, is create a Lambda function that uses CloudWatch.putMetricData. So putMetricData is the API call for CloudWatch for sending a specific metric, and you could be doing anything. You could create a metric named sales volume or tickets opened, anything at all. So in the case of this function, what we're going to do is count the number of reservations. So describe the instance, and for each instance, add that metric to CloudWatch. We have to allow the Lambda function to do this. So the Lambda function role must have the CloudWatch put metric data. And then we schedule the Lambda function. He's running it every 15 minutes, but the granularity, again, depends on your level of paranoia. And once that is done, you can automatically check for your rules. So if you want to say that, hey, I have P2s and M4s, but I don't want to have more than double the size of my M4 fleet in the P2 family. So you can create any kind of rule because after all, it's your function, it's your code, your data. You can just monitor this any way you like. And a very similar idea is valid for config. So config can run your Lambda function as well, but the end result of a config rule is not a metric. It is evaluation of compliance. So here you will have either your resources compliant or not. So let's take a look at the config console. So this is a separate management tool that can take a look at resources in terms of their configuration. So you can, for example, evaluate if you have unencrypted buckets or volumes and things like this. The idea is that you can add rules, and these rules can be AWS managed rules that are ready to use, such as having CloudTrail enabled. So this one will check periodically if you have CloudFormation enabled, and if you don't, set it as non-compliant. Or a specific desired instance type that you want to use. And if there is any instance type that is not on that specific type that you mentioned, it's going to trigger. Or you can add a custom rule, and that's just a Lambda function. And again, your Lambda function can tell what is compliant or not, and return if the rule is compliant or not. So let's take a look at that code. So AWS config. Oops. Developer guide is what I want. AWS config rules, custom rules, examples, functions, and events. An example function. Here you will find a sample Node.js function that evaluates whether the instances match the resource type EC2 instance or something. That's you could be doing any check, really. It's not important. What I want to show you is the results. So here is the most important part. The end result is your function is going to return if it's compliant, non-compliant, or if it's not applicable for the specific event. So you could trigger this either when a resource is created, you could trigger this function, or periodically trigger, because you may be checking for the absence of something, and so you need to check it periodically. And well, that's a good thing that you have these two kinds of rules. But you can see that one thing is the perspective of being compliant with your given rule. For example, if you're under utilization in your resource consumption or above. Or you could monitor on a CloudWatch metric and just create an alarm on top of that custom metric. And those are the ideas that we're seeing here. And again, this is just a couple ways to do it. I will come back to you guys with this implementation. This is as concrete as I have it for now, but I hope we can get executable code examples for this. So as we go deeper in the series, we will keep improving these answers and adding more and more resources. But those examples are pretty straightforward to follow. It's just create your Lambda function and bind it to the appropriate service, And depending on your business needs, you may be interested in more like a metrics-oriented view. That's what I particularly prefer. Or if you're more on a compliance side of things, you maybe just have the config side. Or if you're in a more demanding scenario, you can even have both. Why not? So that's it. And one thing that you can do once you know how to query and evaluate your service limits is to manage them automatically. There is a trusted advisor check about service limits. So let's talk a bit about this thing called the trusted advisor if you don't know it yet. So the trusted advisor is a tool from AWS support that you can find it here on the support center. So is there is the sound running bad? I'm seeing your comments about the microphone, and we did test a lot today. So I'm hoping that there's a sound. Let me just do a quick check. Yeah, I can hear there is some. I can hear there is some background noise, and I apologize for that. That's because my vents are running much higher now than when we were testing this earlier, and we are certainly going to get this better at each episode. I'm just getting this computer closer to myself, and let's see if I can get it a bit better. But in the meanwhile, I managed to disconnect my external display, so I apologize for any minor interruption that we have now. Sorry about this technical issue. We did test this thoroughly, but I don't know why, again, we keep having this trouble. Let me run a quick check for the audio quality. Sorry about this, guys, and I hope we're back and loud. my display capture is looking weird. Now it's better. Okay, so we're back to the AWS well architected on Twitch. Sorry for this minor interruption about the sound quality. I will speak louder, and I'm sorry for the vent sound in the background. I hope this doesn't sound too bad. And right, so I will just continue with the content, and we will get the sound better for the next time. So we were talking about the super nice tool from AWS support called the Trusted Advisor. And here on the Trusted Advisor, on the support console, on the Trusted Advisor, you can see some problems detected. No problems were detected on 30 checks. 619 have investigation recommended, and some of them have actions to be taken. And when we do this on the Trusted Advisor dashboard, you can see in each of the sections of cost optimization, performance, security, fault tolerance, we have this, the service checks. And one of them is about the service limits. So here you can also check if your services are above or below the expected count. And as all other AWS services, we have the automation possibilities for this. So on that GitHub, on a GIST, so let me get that GIST back. And if you don't have that GIST, I will paste again the links. So this is it. Oops. This is the GitHub GIST with the notes, and all of the links and commands that I'm showing today are here. And with the AWS, this Trusted Advisor checks, you can just run this command. It will automatically look for this check in the Trusted Advisor command. I did some pasting wrong here, so let me open that on a text buffer. Oh, it's missing the slashes for the line breaks. So this would not work. Now it should be better. And here we can see that for some services, I'm yellow, I'm at limit, but for most of them, I'm green. But on US East 1 and on US West 2, I am right by the limit. So I should request for a service limit increase on those regions as well. And some of those service limits are fixed. Really mind here in the limits API and in the limits document. There are some marked as hard limits. And those are limits that you cannot increase even with the service limits request. So you may think about sharding or other techniques for offloading the load on those resources and things like that. So that's it for managing service limits. This took already a while of us, and if there is any question at all about service limits and service limits management, take a look at these resources. Finally, there is one last, I forgot to mention, and it's the AWS Limit Monitor solution. So this is an automated verification of this trusted advisor check. So this solution is a CloudFormation template with everything ready to deploy. It will deploy a Lambda function that will check the trusted advisor APIs, and it will notify the results to several destinations that it supports, and it's very, very easy to deploy. The source code is open and available here as well. You need just to deploy the solution, and it will automatically check for that for those limits on your account. So if you want to take a look here on GitHub, the AWS Limits Monitor code is all here, and all you need to do is you can build your own if you like. There are some checks you can customize and change to add additional resources perhaps, but anyway, just deploying this, you add your own accounts here. It's expecting account IDs. So let's pick my own account. And go on with that. So my mail for alerts, and that's it. But, oops, I need to authorize this stack to create IAM resources on my behalf. So, reviews, next, permissions, advanced, nothing here. Oh, here it is. I acknowledge it. This can create IAM resources because it needs to create an IAM role. And here we are. I should get notifications when I'm near the expiration of my, near the limit of my consumption. But you have to remember that this solution is bound to the Trusted Advisor API, and those checks are only available for business support. So you should have business support plan to deploy this solution. So this is one gotcha that may drive you to select one of the other methods that we discussed below. So right now, today, we did the automation using the AWS Limit Monitor solution because that's as easy as deploying a CloudFormation template, and not much to worry about that. But on the future episodes, we can try implementing this as CloudWatch alarms or as config groups. Okay? All right. So, oops. Sorry about the wrong link. Thanks, Gina, for fixing that out. The next question about the next reliability question we are going to talk about is about your network topology. So let's talk a bit about Route 2, how do you plan your network topology on AWS? And here the idea is think about how do you connect back to your data center. If you don't need connectivity back to your data center, then this is not much of a trouble. But if you need to have a connection back, then we have to think about high availability for those connections. And it depends on the kind of connection that you have. For example, if it's for a batch process that will be retried or for just day-to-day office communication, then perhaps you may choose the not high-end, so highly available solutions. But if you need to guarantee, like if you have, for example, a database in a mainframe, for example, in one data center, and you need to connect that to your AWS application or something like that. I hope that's not the case for you, but we know that happens. And there are a couple of alternatives for this. One is Amazon Direct Connect, AWS Direct Connect. With AWS Direct Connect, you can connect your data center directly to AWS. Directly, I mean by direct fiber. And this is a straight link without passing through the internet. But it does have additional charges, both by AWS and the APN partner supporting AWS Direct Connect will have you'll have some costs associated with this. So it may not be the case that you want two AWS Direct Connects. I mean, for high-end, high availability, you may need two separate AWS Direct Connects. But what I see in many customers is having a mix of AWS Direct Connect and VPN tunnels, so you can set a VPN tunnel directly to your VPC, and over an encrypted tunnel on the internet, connect to your cloud resources. It's certainly not, it's not as secure as a direct connection because you have multiple points of traffic instead of just having your dedicated traffic, and not as reliable perhaps, but you can manage. So perhaps if you have a direct connect as your primary link and a VPN connection as a backup, that may be okay for your AJ scenario. Or if for some cases, even two VPNs or three VPNs may do the job. It depends a lot on what you're passing through those connections, of course. I just would like to show that these two options exist. You can either connect directly by one hop to your data center to the partner and one to the partner to the AWS region. So you should have that nearly worldwide. We have hundreds of connection points by now, and this should be interesting to most people that do have a AWS production workload integrated with on-premises. But if you're doing connection for data test or for enterprise softwares, perhaps the VPN connection is already good enough. Do evaluate this. And there is another possibility here is using third-party VPN software. So if you already use OpenVPN or something like this, you can keep using the same VPN software that you already use, but do it also on the cloud. Maybe you want to reuse configurations, licensing, and things like this. This is a third possibility. And I added here two very important links for planning those connectivity when you have multiple data center and you need AJ connectivities. So you may have your own custom traffic routed by your WAN or your own network, private network, and have different customers' gateways to AWS, so you can route traffic either way. If something bad happens, you can reach through your other data center, and this is a very common solution that's again implemented here in this AWS Answers website, where you find many of those pre-built answers for architecting your solution, but reusing some best practices that we found. So this one is for multiple multi-VPC connections, so how you mesh services in several different VPCs, and how do you create this transit VPCs, and so on and so forth. So we're not going to go too deep in VPC design. I just want to show you how to do it as code. So let's take a look at a CloudFormation template that describes VPCs and a few more features of CloudFormation that I believe you might like to know. So let's jump right into this template here. So I tried to create a template to show you guys how to define software-defined networks using CloudFormation and Amazon VPC. Here I'm creating what resources? I'm creating a VPC, and you can see what the things I'm creating by the type, not by the name. So this could be any name. I'm just saying that the type of this resource is a VPC. And what is the address of my VPC? Is a reference to another element called CIDR block. And CIDR block is a parameter of my CloudFormation template. So when someone tries to create this template, it will ask for this parameter CIDR block on this default value. And to create a highly available setup, we need a couple of different things. First, define a network topology. And my network topology here is very simple. We have public network and private network. We will have our resources such as application server, web server, anything that needs to be reachable from the web on this public CIDRs, so subnet pub A and subnet pub B. So we have a very basic redundancy. Only two subnets in this case for a very simple template. You could use more of those, and also private subnets, because resources such as databases or Elasticsearch clusters or cache clusters, those kinds of things, you may not want to put on with a face on the web. So no, I'm actually with my mic pretty close. Actually, I'm trying to get it as close as possible. I'm sorry if the sound is not too great today. Is it too low, or I will try to improve I will add a little bit of volume on my sound settings and try to see if that makes it better. The problem is that also will make you hear a bit of my fan, but let's go with that. So I increased the volume a little bit. Let me know if that makes it better or worse. And again, I'm improving this every time. I'm sorry about this, and we're gonna have a better sound next stream, I promise. For the resources on your environment, we can keep doing the same kind of reference, but referencing other elements from AWS. For example, here in our public subnet, we're going to reference one VPC ID, So what is the VPC ID for this subnet, for this public net? It's a reference to my environment VPC. What is the CIDR block for the subnet pub? It's a reference to the subnet pub A CIDR, so this parameter. What is, so on and so forth. So this is how you make references. Note that you can reference either a VPC element, so those references reference this resource, or you can reference parameters, outputs, and a lot of different things in CloudFormation with ref. And then a very important difference between public and private subnets. Map public IP on launch. So you can see that on our public subnets, this is going to be true, and on our private subnets, this is going to be false. So, yeah. Okay, perfect. Glad to hear. Thanks for this. And sound on streaming is a bit on many different factors, and I truly appreciate your understanding. And let me know if it gets too bad, if I'm speaking too loud or too low. We're going to keep moving through the CloudFormation template. So the next thing here, and it's a pretty important detail for high availability, is saying in which AZ this is going to be. So we don't want to put our subnet A and our subnet B in the same availability zone, but we could ask for parameters here and ask for the user in which subnet he wants to put, in which AZ he wants to put each subnet, but then you would have to validate that one, they're not the same, because you don't want two subnets in the same AZ, because if we have trouble in that AZ, you're going to need to failover and things like this. So, and another thing is you don't know what AZs are available to you. So take a look here in my EC2 console. You will see a very important detail of EC2. That's the availability of AZs is different between accounts. And even in my account, the AZ named US East 1A may not be the same place that your US East 1A physically. And see that I have access to A, B, C, D, E, and F. So this is for my account. Your account may show something a bit differently. Let's see, for example, in São Paulo region, you can see that I have less and that they may be named differently. Here I have A, B, and C, and so on and so forth. So we are doing quite some tricks here. Let's go through this AZ selection example in detail. First, I'm using the function called getAZs for a given region. AWS for dots region is the name of a special parameter for CloudFormation that gives you the region in which this template is being created. So I'm going to get this list of regions and get this region and get the AZs of those regions, and from those select the first for one subnet and select the second for another subnet. So a small CloudFormation trick there. Just again, so that I don't have two AZs, two subnets in the same AZ, I select different AZs automatically for each one by getting the AZs of the region and selecting the first for one and the second for the other. And another thing that's important to make these instances public and private. And this is a AWS certification exam, actually, a question on the exam. What are the resources that you need to ensure an instance is reachable from the internet? It's not only having a public IP, you also need an internet gateway. So I create a gateway to the internet, I attach this gateway to my VPC, I create a public routing table for my public subnets, a private routing table for my private subnets. I route the public to the internet by creating a route on the public routing table saying that everything that's 0000 goes to the gateway to the internet. And everything that's on subnet A and B will be associated with the public routing table, and everything that's associated with the B network, the private networks, will be through the private routing table. So this is how you can control routing on your VPCs. And this is for the public network, because the public network goes to the internet through the internet gateway. What about the private network? How can the private network go out to the internet? The private network must go out to the internet by a NAT instance or a NAT gateway. So in this case, I have a resource that is a network address translation gateway that will forward all traffic from the public, from the private nets to the internet through the subnet pub A. And this will be just NAT, so this will be just outbound traffic. For example, if your database needs an update or something like this. So that's how you can route and then define a route on the private routing table saying everything that won't be in this address space goes through the NAT gateway. And so this is how this is. Let me share with you this with the same gist that we are using. So I'll create a new file on this gist and update it with this template. All right, so now you have the same file as well. And how do you create this by the command line? So I also created this shell script, very simple one, to show you how we can create this file. So I'll create a new terminal window here. Set a new one, set up my profile, and I'll add a unique name to this, and create a stack name. I will call it Twitch, and that unique name. Then I'm going to create this stack using this stack name that I just invented, composite of Twitch and the hours, minute, and second of now, using the template body that we just mentioned. But let's take a look about what about the parameters? What about the things that are referenced, that are user defined? If we take a look at that template again, I'm talking about this CIDR blocks. By default here, I added 192.168 as a CIDR block, But for your environment, let's say, for example, you are already using this in your own data center, as we were talking in the collisions subject, you want to use a separate address here. So I may want to change this to 10 networks. I can bind these parameters in the JSON file and pass as parameters to CloudFormation create stack just like this. So here I'm running this on my own computer, but you could run this from your Jenkins server, from AWS Code Build, from anywhere you can create a CloudFormation stack, or even on the console if you would like to do this by hand. But as we're doing things automatically here, I would like to show you how you can do this with code. And here we have a new stack ID for these resources, and let's see what it is doing, right? So on AWS CloudFormation, we have this. Oh, I had a problem in the limit monitor setup. Probably tested some wrong setting. We can look into that later. But here it's creating all the resources in my CloudFormation template. And one very important thing that you see here is it will either create all resources that I have defined or create none. If this public route to the internet that takes a bit longer to create fails by any chance, CloudFormation will roll back and delete everything, so you don't end up with like a partially defined architecture or with bad reference resources, and when it's time to delete, you delete everything as a whole as well, or update it as a whole as well. And this make it much easier to manage your resources. So let's go to the stack details. And wait just a bit. This should not take long. And well, we can already see on the resources what's going on here. So let's take, for example, this subnet. So it was created a subnet, and this is it. And this is the public subnet A. If we go to the VPC console, just to double check, and check our subnets and filter for that specific one. And here we can see a couple things. First, my subnet was created with the parameterized CIDR for my JSON parameter file. It's referencing the correct VPC. Its route table has the local route by default and the route to the internet gateway that was created for me. And the internet gateway is bound correctly to the VPC. And you can easily see how hard it is to create those things by hand. And create VPC, create subnet, create load balancer, create net gateway, create this, create that. It's certainly very error prone if you do it by hand. Doing it in a CloudFormation template makes it very much easier not only to create but also to update. Say that you need an extra element for any reason, you can just go here in actions, update stack, provision a new template, and change your template as you'd like. And if your template is under revision control and together with your source code, if you change your architecture, it's just a code change like no other. So it makes CloudFormation a very, very interesting tool to be able to create new environments easily, test simulations, creating new customers, or deploying your software more flexibly. So that's it. Let's continue on the questions and on the best practices. So following the high availability of connectivity that we are talking about, and this is talking about your connection from your on-premises resources to AWS, we need to also think about how to connect our workload to the cloud. And here there are some different tiers that your workload may have. So you may pass by Route 53, you may pass by CloudFront, you may pass by ELB, or all of them. But it's important to know each of those services. So I'd like to highlight Route 53. That's our managed DNS service, and in terms of reliability, it's impeccable. So if we take a look at the Route 53 SLA, I know that I shouldn't say that for most things, and it's maybe not too humble of me to say this, but in the definitions of the service level agreement for Route 53, it says that its goal is to be 100% available. If it's not 100% available, or if it's not impeccable, you are entitled to service credits. So that's a pretty strong statement for the reliability of Route 53, because of course this is the service that routes all DNS queries to Amazon. So, and most of the customers that use the service. So you can imagine that this is pretty important to be reliable. And a few things to consider, a few important features about Route 53. So one is routing policies and understanding so I'm using Visual Studio Code. Surely, I'm a huge fan of VS Code, and it's pretty unique in the way it handles some things such as this character and zooming that makes it very good for streaming, but that's it. I've tried a bit of everything. We can use VI or any other IDE in the next, or even the Visual Studio tools and Eclipse tools. There's a lot that we can say about the IDEs in the cloud. We can talk about this in a future episode, because we need to talk about the Route 53 routing policies now. And the routing policies is the behavior that Route 53 can have when you create your routing, your queries. So let me go to Route 53 and show you guys what I mean exactly. Oops, not that one. So when you create a Route 53 DNS record, first you need to create a zone for this, and I'll create a zone for my domain called twitch.com, for example. Let's say I bought twitch.com for myself and registered this domain. When I'm going to create my record sets for this, oops. There are 5 routing policies that you can select. So you can have your simple routing policy, and that will send all queries directly to the address that you specify. So if you say that twitch.com is this address, it will map 1 to 1. You can have weighted records, so you can say, well, answer out of 5 questions, answer 4 with one value and 1 with another, so you can send most of the traffic one way and part of the traffic other way. Latency based will resolve to the server that has least latency in relation to the user. So this will estimate the distance, the network distance from the user to the resource. And if you have 2 servers, for example, 2 IP addresses for the same name, it will answer with the closest one to the user. Failover will always respond with the primary address unless it health check fails, and then it will fail over and return the second. On geolocation, it will return the closest to the user, but as a geofenced definition, so you can say, you can be more specific and reply from the Texas server to the Texas user or to the UK server referring the UK user, and you can even combine those values and create your own DNS policy with more than that. So this makes CloudFormation a pretty Route 53 a pretty functional routing, and I highly recommend that every DNS domain that you have, try to use Route 53 if possible, because it has, like I said, impeccable uptime and very flexible routing policies that can make you do very interesting things. One very important thing that you can do is bind not only to an IP address, but to an alias. And what it means is, instead of saying to AWS, to Route 53, what is the IP address that I want, I will bind it to a target name that can be an S3 website, an ELB, a classic load balancer, a network load balancer, a CloudFront distribution, a Beanstalk environment, or whatever. So you can reuse TPL and DNS configurations and bind it to your root resource without having to worry with any more than this binding. So this is very convenient to route traffic to internal AWS resources. And the last thing on Route 53, now this is it. And when routing to the next layer that I would like you to consider is Amazon CloudFront. So if you take a look at AWS Amazon.com/products, other than this huge list of services, you have this map of global regions and edge locations. And it's important to understand this distinction between this blue and this orange dots. These orange dots are the regions and the things we've been exposing so far, but we operate a different kind of infrastructure called this edge locations. And these edge location pops are the places closer to the user, so you can see that we have much more of those, and any user will probably have a closer edge location to them. And this runs the services that must be close to the user. First and foremost, as we were talking, Route 53 for DNS, but also your content delivery can come from this. You can use a CDN, and this would be CloudFront. So this is also very important for availability, because if you are down on your backend, or if you're latent, or anything happens on your backend, you can keep answering from cache and use several techniques to make this better. One thing, for example, is as you keep it cached in the edge locations, you will have less load on your backend and also save a lot of money. If you are being under attack, under a DDoS attack, for example, you have an outer layer of protection that must be passed before you even get to your servers and resources. So, and there you can do web application firewall, you can exclude traffic, you can even do computation and run Lambda functions on this edge box. So it's very important to use CloudFormation, CloudFront, whenever possible, and we're going to do that. Some things that people ask very often, and some features that I'd like to highlight in this episode that we are going to use a lot in the future is first cache expiration. So determining how much time things are in the cache in CloudFormation is done by setting HTTP headers. So especially the cache control max age directive. So for example, you can return for your HTML, CSS, JavaScript, everything that can be of a high max age can be cached forever potentially. If you're using a static web client compiled by GWT or React that you can generate hashes for names, you can have perfect caching and cache those things forever. Or if it's hot data that you can't cache at all, you can put max age 0 and CloudFront will never cache this. And so you can say exactly how long things stay in cache. And if you make any mistake, you can always invalidate cache and start from new. Another important resource of CloudFront that you won't find in many CDNs is Lambda. So with Lambda at Edge, you can put functions when the CloudFront receives a request from the viewer. After it requests to the origin, if it was not in cache, when it comes back from the origin and right before content is delivered to the user. So you can actually create a function. For example, let's take some example functions. I think there is one for generating responses or working with query strings. So it's a regular JS function, and you can even output content directly from your CDN. So you can evaluate security headers, you can do whatever you want, and rely on the high availability and global distribution of the CloudFront. So that's the idea. And if you need to secure content, CloudFront has two features for secured content delivery, which is signed URLs and signed cookies. We're going to talk more about this in the security episode. I just like to leave it linked here because it's such a common request to serve private content. How do you make sure that your videos and media are only distributed to your subscribers and things like this? This is the way to go about this. So I decided to try to link to that as well. And also in this poorly marked link, you will find something I find useful. It's compressing automatically. So if your client can gzip files, CloudFront can automatically gzip your CSS, JavaScript, and things like this for you, so you don't have to do this in advance. Even the elastic load balancers are highly available. So when you are doing your load balancing on AWS will provision you with a name, with an endpoint, but behind the scenes, you're going to scale this to many load balancer instances. And this is why it's important to never reference an AWS load balancer by IP addresses, because those change. They come and go, they go up and get down as the application load balancer scales or any of the load balancer scales. So make sure you always reference the load balancers by name. And choosing the correct load balancer is really important. So the application load balancer, as the name implies, is for the application protocol. It understands HTTP. It can do high-level application features such as dynamic porting binding to Docker containers, sticky sessions, and things like this. The network load balancer is on the layer 4. It's on the transport layer, so it doesn't understand the application. It just goes directly to. Yeah, so I'm glad that you're liking Twitch. We're here with this AWS well-architected episodes. We're running twice a week this month, and we're going to explore a lot more of the framework. Keep on in tune. And the classic load balancer is for old applications that use the classic load balancer, the ELB, the traditional version that was superseded by the application load balancer. Like, I don't think of much scenarios except for compatibility why new workloads should use the classic load balancer these days. Perhaps I'm wrong, but using the ALB is better by now. But in either case, they are all highly available. And you can see that if you use this combination of Route 53, CloudFront, and ELB, you have 3 layers of managed services managed by Amazon with a high level of high availability, and you will have a much more reliable solution than if you just put a public IP on your machine, right, and expose your machine directly on the internet. Even if you need one IP address to a machine, one trick that I recommend is that you can use an IP address for your application load balancers and put a network load balancer in front of that. So you have the IP address from the network load balancer, and you can direct the traffic of that to the application load balancer, and then have best of both worlds, and still don't need to put an instance with its public IP address directly on the internet. Don't do this because you'll be vulnerable to port scanning, to all sorts of bugs that may exist in open ports that you don't even know, or whatever. Don't put servers out in the open on the internet is probably a good idea, especially when you have all those services just pay-per-use, so they don't cost, their cost will probably be negligible. And in some cases, such as CloudFront, as it offloads to cache a lot of the processing that you do in the back end, it will likely cost less in the end. So we will get the best of both worlds. And of course, for enterprises that already uses F5 or CAMP load balancers, you have those available on the AWS Marketplace as well. So, Calderon, for a network load balancer, I would say the scenarios for that are when you're not using HTTP. So when you're using protocols that are, for example, media protocols, RTMP, calls, telephony, anything that's beside the usual protocols that will be under layer 7. And when you need an IP address, when you need a direct connection to an endpoint, but in the back, you may have several servers. So especially when you use enterprise software, telephony software, things like this, we need one IP address as an endpoint, and you can have that in the network load balancer and have a fleet of backend machines running that. But they will not be aware of the protocol, but you don't want it. And another thing that's a very important thing is about compliance. So say you want to have HTTPS and you want the certificates on the instance. You can't go unencrypted you need to go encrypted down to the instance, and you need HTTPS on that. With the current, there are some ways you can achieve this. For example, you can have two HTTPS connections, one to the ALB and another one from the ALB to the instance. But if you want one single direct HTTPS connection from the user to the load balancer, to the app server instance, you don't want to intercept the encrypted connection. You want just to pass the sockets directly, and that's what you would have with network load balancers. So those are the three most important cases: custom non-HTTP protocols, the specific IP addresses, and direct HTTPS to the backends. So I hope that makes it more clear. And again, don't use overlapping ranges in multiple VPCs, and look for, when you're using subnet allocation, do remember that those expand. So if you have 250 application servers in a single subnet, you may want to offload those to another subnet so you have enough addressing space for the load balancer to grow, because the load balancer will consume the same IP ranges that are on your subnet, on the subnets that you put it in. So that's another important point. And last but not least, we're going to see how does your system adapt to changes in demand. So that's the idea of auto-scaling, serverless, managed services, and all the services that AWS do. But they differ a bit, and there is not really at least I don't know any official names for this, but there are some names that we use a lot. So I'd like to familiarize yourselves with this, and on how the workloads scale automatically and how those services are managed. So first we have some global services, and when I say global services, I mean the services such as Route 53, CloudFront, IAM. You don't have any control of those services. They are totally managed, scaled, and maintained by AWS, and there's not much you can do about it. They are just there, and they will keep going. So you don't have to think too much about the global managed services. Next down, you can have serverless services. And when we talk about serverless services, I'm talking about services like AWS Lambda, in which once you configure it, it goes without your intervention. You don't need to scale it up or dial it down. Any Lambda function will run, and AWS will fire as many copies of that as necessary until it reaches your limits, of course, but you don't need to worry about the management of this. It will work up to the concurrency limits set here. So for example, in AWS Lambda, if you're doing a database request, for example, a query, and another request comes, it will start another one, and another one, and another one, until you have 1,000. That's the limit for this function concurrently. And this is unreserved, or you can reserve. You can say that this specific Lambda function, I want to allow only 20 concurrent executions of those. So this is a bit under your control, but not so much, right? Another different thing is when services are auto-scaling. So Services are auto-scaling would be such as EC2, auto-scaling groups, or DynamoDB, or ECS. Those are servers that react on demand. And I'd like to show everyone how this works on the bare bones. We're going to see more advanced examples of that. Let's start with a very basic auto-scaling route so that everybody gets what I mean by auto-scaling. So I don't have this on CloudFormation yet, so let's do this one by hand and create an auto-scaling group and a launch configuration for us. So I'll start with a launch configuration, and that's exactly the same settings that I need to launch an EC2 instance. So AMI, I will pick a given instance type, I will configure the details, I want one of those, sorry, I will have this as my Twitch launch configuration, and I'll enable detailed monitoring. I can use this defaults for everything. The only thing I want to do here is run something on these instances. So I will use bash to install a web server on this instance and say hello. So yum install HTTPD, service HTTPD start, and I will echo my ID equals the, or let's just go with a simple HTTPD start. I would create a custom page or something like this, but let's go with just HTTPD. So just bin bash, install HTTPD, start the service, not worry too much about it. And the for storage is fine. As this is a web server, I'll call this group Twitch Webs and allow HTTP on it, as we're doing HTTP on port 80 from anywhere. So we got our launch configuration, and I'll create a new keeper just so we can access these instances. Remember that there is no copy of this file, so please don't share it with anyone. Keep it safe, because if you lose it, it will be very hard to access your instances. So Twitch, after the launch configuration, I'll create the auto-scaling group. And here I'm starting with just one instance, and I will start in my default VPC, and I will use this and this. I can select as many subnets as I'd like. And it's weird that it's got this addresses, but let's go on. And I can receive traffic for load balancers if I want, and bind those to load balancers. I don't need this by now. What I really want to show to you guys is this auto-scaling groups. Instead of keeping it at its initial size, I will use auto-scaling policies and scale between 1 and 10 instances, for example. And I can select different metrics for the group size, but I will just, I don't know, keep it with just one as a target values. So you can also set up the steps for creating and setting up the sizes. This wizard is not so easy to see. I will keep it at its initial size and create the policies later, because I think that's easier to understand. And I can add notifications to this, create the auto-scaling group, and just create the auto-scaling group with a single instance for now, just to test if it's working okay. And you can see how auto-scaling works. So here in instances, we probably can see one instance coming up as our auto-scaling group specifying one instance as its minimum. And here we go. This one is initializing, and it will soon be ready for service at this address, hopefully with a sample web page. On the management console, I can define the policies to scale this resource. And there are many different ways to set this up. I will do it very simply for today, and then we can proceed with a simple auto-scaling policy. I will create a policy called scale up. And then you have to say when you want to scale up. I will scale up when the average of CPU utilization is higher than 80% for one period of 1 minute, or I could say for 2 periods of 1 minute or whatever. I just want this to trigger fast, so we don't need to wait too much. And then when this happens, you can add one instance. And so on and so forth. You can create more and more policies and scaling actions to scale up and down as your request environment changes, as you get more load, as you consume more memory. Remember that we mentioned about custom CloudWatch metrics in the beginning of this episode, talking about service limits. You can have custom CloudWatch metrics and react any way you like. So let's go on to the monitoring. See if this instance is live. Let's try to connect to it directly. So on the downloads, where my key probably is, I have to change the permissions as I just downloaded it, and then I may be able to access this instance. Or not. Not so available yet. I don't know if it's some issue with this VPC. What's going on here? It's got a public IP. Let's see if this public IP, if this VPC has got, as we were talking a bit earlier, it's got to have the internet gateway. So let's go to the VPC console. And check if the subnet is public really, or if it's fooling me, because I don't know why this is not connecting. So I will just double check that what is the subnet? It's the EC subnet. This one. On its routing table, it routes to the internet gateway. Oh, it is the attachment. So let's attach to the VPC and attach it to the default VPC. So now this works. See? Everything on an instance needs to be public, is a public IP and attachment to an internet gateway. And here we are. So if the instance is reachable here, We can probably also reach it by its public DNS name and see if its web server is running and that command I did run well. But what I want to do is put some load on this machine. And putting some load in this machine to test the auto-scaling groups could be done in different ways. And I listed some load generators here in the load testing things that we could do now. And again, I will do some manual load testing here, but in future episodes we may use these tools, and I'd love to hear what you think. Those two first are my favorite. I do JMeter a lot, but JMeter has a bit of a clunky UI, so Gatling has a DSL based on Scala, so tests are programmatically defined. If Scala is not your thing, there's localhost on Python, or even Vegeta that you can just use your Dragon Ball Z skills to define a list of requests, and it will fire away those requests at the server. Bees with machine guns that can spin up EC2 instances to run your tests in parallel and put a swarm of T2 micros to fire against your server. Serverless artillery does similarly, but with Lambda functions. And for the really old people out there that wants to do distributed testing, you may still find around some tool called Grinder that was really popular for a while in the Java circles. All those would probably work fine for basic scenarios. If you're into something more professional, I don't know, my tool of choice that I know the best is JMeter, but it's a bit old and clunky. I'm trying to get refreshed and learn a bit of Gatling. In the future episodes, we can have some shooting and terminating those instances, because right now I'm going to do it synthetically by just copying things from VD, using VD from the dev node. Oops, I will read from dev 0, write to dev node, and put this in the background. So read from nothing and write at nowhere, and doing this a couple times should get our CPU certainly busy at 100%. And as our monitoring goes, we should be able to see this in about a minute or so. And when our CPU triggers above the 100% threshold, it will match the auto-scaling group last setting that we created. Remember that we have here the scale up policy. When I breach the alarm that I have more than 80% CPU for more than 60 seconds in this auto-scaling group named Twitch auto-scaling, I will take the action to add one instance, and then I will wait 300 seconds to wait for things to cool down before considering taking another auto-scaling activity again. So let's see if we can see it's already on 60, and again it takes you can see that it takes a while from the monitoring, like a minute or so for the monitoring to pick up. So the vision that you have is not so accurate, perhaps. You have to do like real-time accurate, but for most cases it's good enough. Certainly when you have more scale and your averages are more meaningful, you can give it a better adjustments. But the overall idea is it's hard to define good CloudWatch metrics that follows your workload very, very closely. The idea is give yourself some space and start doing by CPU or by memory or this rough lines, and then you get more rules, more metrics, more alarms, and get closer and closer to your production workload, to your exact, and waste less and less. So we have this at 100% now. So our alarm is probably triggered. It will be triggered in a while. And as soon as we see it fire, we will have the new instance coming up. And if it was registered to a load balancer, it would be added to load balancer automatically. So you see here the desired is at 2, and on instances, you can see that I have a new instance coming up to be part of that auto-scaling loop. So I hope you can see the difference here. This was all to show you guys the difference between global, serverless, and auto-scaling. And provisioned. Provisioned would be the not auto-scaling, that you would come here to new instance and launch one additional instance yourself by hand. So you can see that you can choose, and different services may work a bit differently. Some services are global, such as Route 53, CloudFront, and that you don't need to even think about. Some are serverless, such as Lambda, S3, Elastic Load Balance, in a sense that you don't have a server to manage, or you control very little of how that goes in terms of scaling. Some are auto-scaled, such as EC2, Dynamo, and things like this, that you can auto-scale, but you have to say how, and when you want more, and when you want less capacity, and in some cases you might need to provision things by hand. So with this, oh yeah. Yeah, I said 80%, yeah. And thanks for catching my typo on the HTTP. Glad to see you guys are alert. And again, the choice of workload testing is a hard one. There is a question about if you need to be distributed or not. If you need to do it distributed, the JMeter and these with machine guns are very, very practical. The other ones, like Gatling, has you can use a centralized database yourself, or buy their premium version to get distributed testing and things like this. Vegeta works really well with automation and is really fast. So it depends a bit on the use case. We don't have enough time today to run through this, but we can have perhaps in the future an episode showing the best and the worst of each one and how it relates to AWS. We're certainly going to pick one to fire some shots at our workload and our applications, but that's something for the next episode. For this one today, I hope that we are already talking about reliability for almost 2 hours now, so I think it's time for us to take a break. So we did reliability 1, and we talked about managing service limits, and we talked about planning network topology, and here on this list you have our basic network topology defined as code in CloudFormation. Again, this is the link for the GIST. And finally, we took a look at how do your system adapt to changes in demand. And the most important advice here is to favor the services up in this chain. So the most you can use of global, better. And the most you can use of serverless, the more you leave to AWS to manage scaling. But it's in practice, you may see things that you may have to auto-scale or provision by hand. And we did some artificial loading, use a fake DD load, just copying stuff to force the CPU to act. But in the future episodes, we're going to use this load test and load generator to send some more traffic to our service. And that's it for today. Thank you guys very much for standing by and watching. I'm sorry for the audio issues that we had earlier today. We're trying to tackle this down, and every episode we're getting better and better sounds, and we're going to be testing with more people and getting it right for everyone in the next ones. Thank you guys, and see you next time this Friday with performance tuning, and we're going to see how fast things can go. See you.